In California, there is a fundamental rule of survival. Fire is the ultimate predator. A single spark in the wrong canyon can erase a town in minutes. You don't wait for it. You don't negotiate with it. You attack it with everything you have. But right now, on a highly populated stretch of the American West Coast, professional firefighters are doing something that defies every instinct of their training. They are standing down. It is April 29th, 2026. We are looking at Marina Drive in Hope Ranch, Santa Barbara County, one of the most expensive and exclusive zip codes in the United States. Directly beneath these estates, the ground is exhaling. The air is thick with the choking stench of sulfur. The heat radiating from within the rock is so intense that underground PVC drainage pipes are literally melting and catching fire inside the slope. Yet there are no evacuation sirens. There is no panic. The battalion chief on the scene has issued a directive that, in any other California fire zone, would be considered absolute madness. Monitor. Do not suppress. They are watching it burn because they know a secret about this specific cliff. A secret that the modern world has largely forgotten. They aren't ignoring an emergency. They are bearing witness to a geological anomaly that forces our modern infrastructure to its knees. Before we go any further into the anatomy of this anomaly, I need to know where our monitoring network is active tonight. Drop your city or coordinates in the comments below. In a world where systems are shifting faster than the headlines can report, we need to know who is paying attention. Welcome to Plasma Pulse. Let's get into it. The men and women of the fire department are not pulling their hoses because they have recognized a terrifying pattern. What is happening beneath Marina Drive does not consume brush. It does not ride the wind, and pouring water on it might actually make it worse. If the fire department doesn't consider this a wildfire, if they know that standard suppression tactics are utterly useless here, then what exactly is burning beneath the mansions of Hope Ranch? And more importantly, what happens when human beings build their most expensive infrastructure directly on top of an ancient sleeping engine? That suddenly decides to wake up? Enos, to understand the sheer absurdity of this event, you first have to understand the geography of denial. Hope Ranch is not a remote stretch of unmanaged wildland. It is a highly manicured enclave. It is a community defined by private equestrian trails, pristine polo fields, and sprawling estates that look out over the Pacific. The people who live here have engineered a perfect, insulated reality. But geology does not care about zip codes, and it does not care about property values. If you stand on the bluff above Marina Drive during one of these events, your senses are immediately assaulted by something that doesn't belong on a pristine beach: the smell of sulfur. A heavy rotten egg pungency that catches in the back of your throat. Then, there is the heat. It shimmers off the rock face, warping the air. And hidden within that heat is a detail that changes the entire scope of this investigation. During the April 2026 event, an underground polyvinyl chloride, or PVC, drainage pipe buried deep inside the slope of the cliff ignited. Let that sink in for a moment. Plastic does not light itself on fire. PVC requires sustained extreme temperatures to melt, let alone combust, which means the heat is not rolling over the surface. The heat is inside. It is moving underground, traveling through the porous rock, finding its way along seams and pathways that nobody on the surface can see until it encounters human infrastructure and simply melts it away. When the fire department pulled up and saw that melting pipe, the situation immediately shifted from suppression to observation, because what they were looking at, despite the smoke and the heat, was fundamentally not a wildfire. A standard wildfire is a horizontal predator. It requires a continuous fuel bed. Grass leads to brush, brush leads to small trees, and trees lead to the canopy. It has an advancing edge, a flame front that aggressively consumes oxygen and vegetation. The entire doctrine of Western fire management is built on cutting off that fuel, starving the beast before it reaches a town. But look at Hope Ranch. There is no advancing edge. There are no embers being carried on the wind. The dry coastal brush, sitting just inches away from the smoke vents, is completely untouched. This is not a fire spreading across a landscape. This is a cliff ventilating itself. The smoke is escaping through structural fissures, acting exactly like the exhaust pipes of a subterranean engine. You cannot fight this. You cannot point a hose at a cliff face and hope the water magically penetrates 20 feet of solid sedimentary rock to reach the thermal core. Even if you could, introducing cold water into a superheated, enclosed geological space could trigger steam explosions or accelerate the very chemical reactions you are trying to stop. So, you wait, you monitor, and you let the rock do what it is going to do. But human psychology hates an unsolved puzzle. When the brain encounters heat, smoke, and the overwhelming stench of sulfur, it immediately searches its database for a category that fits. And for over 2 centuries, the residents of Santa Barbara have reached for the exact same word. They call it the Hope Ranch volcano. It makes perfect sense visually. If you showed a photograph of this smoking cliff to a geologist without telling them the location, they would immediately classify it as a low-temperature fumarolic system, a classic volcanic vent. But here is where the story shifts from unusual to entirely anomalous. The geological mapping of the Santa Barbara region, refined over a century of exhaustive surveying, reveals a stark, undeniable truth. There is no magma here. There is no volcanic arc. We are not sitting on a mantle hotspot. We are not near a subduction zone. The geology of this coastline is built on ancient, uplifted sedimentary seafloor and transformed faults where plates grind past each other horizontally. Neither of these environments produces magma. The nearest legitimate volcanic system is hundreds of miles away. The census say volcano. The geology says impossible. Hope Ranch is a geological impersonator. It is producing all the violent, terrifying outputs of a magmatic system, but it is being driven by a fundamentally different underlying mechanism. It is a fake volcano that produces very real infrastructure melting heat, and this isn't a new phenomenon. It isn't a byproduct of the modern era. To find out what is actually burning beneath these mansions, we have to go back to a time before California even existed. We have to look at a Spanish colonial record that suggests the event we are seeing today is just a whisper of what this coastline is actually capable of. For a California firefighter, seeing smoke rise from a dry coastal bluff triggers an immediate, autonomic response. The protocol is hardwired through decades of catastrophic losses. Deploy the lines, flank the perimeter, establish a containment box. You do not give the fire a single inch, because an inch becomes an acre in seconds. But as the battalion chief steps out of the command vehicle on Marina Drive, that protocol crashes against a reality that simply does not compute. To understand why these elite responders deliberately stand down, we must dissect the anatomy of a wildfire and analyze exactly why the Hope Ranch anomaly breaks every law of combustion biology. A standard wildfire is, at its core, a predatory organism. It requires a continuous, unbroken medium to survive, what analysts call a contiguous fuel bed. It moves by actively reaching out. Radiant heat from the advancing flame front pre-bakes the vegetation ahead of it, driving off moisture until the brush reaches its flash point. Convection columns carry superheated air and glowing embers upward, spotting new fires miles ahead of the main line. Wildfire is a horizontal phenomenon, a wave of kinetic energy actively hunting for fuel. Western fire suppression is built around defeating this behavior by breaking the chain. You cut a fire line down to mineral soil, starving the organism of its path. You attack the geometry of the flame front. Now look back at the cliff face directly beneath these multi-million-dollar estates. The smoke is thick, acrid, and undeniably real. But where is the flame front? Where is the aggressive horizontal spread? Just inches away from the active smoking vents, the dry, sun-baked grass remains perfectly untouched. There are no embers being carried on the ocean breeze. There is no creeping line of combustion eating its way through the underbrush. Instead of a wave moving across the landscape, we are looking at a series of isolated, rigid, vertical columns. The smoke is not billowing from a burning canopy. It is jetting directly out of solid, sedimentary rock. It is escaping through jagged tectonic fissures in the cliff face, behaving exactly like the mechanical exhaust of a subterranean engine. This presents emergency responders with an impossible tactical nightmare. If you cannot physically see the source of the combustion, you cannot suppress it. Imagine aiming a high-pressure fire hose at the side of a mountain. The water blasts against the cold outer layer of shale and simply runs harmlessly into the Pacific. It never reaches the thermal core, which might be buried 20 or 50 feet deep inside the bedrock. Furthermore, introducing pressurized water into a confined geological space, radiating temperatures high enough to melt buried industrial PVC pipes, invites a catastrophic phase change. Water expands 1,700 times its volume when flashing into steam. Pumping a hose into those superheated fissures could trigger a violent steam explosion, shattering the cliff face and destabilizing the mansions above. This is the defining psychological terror of the Hope Ranch anomaly. It is not dangerous because it moves fast. It is dangerous because it ignores the established rules of disaster management. It neuters our most advanced suppression technologies, turning highly trained firefighters into helpless spectators. It is a threat that mimics the sensory cues of a fire while operating on an entirely different set of physical laws. If the fire department refuses to treat this as a wildfire, then why do all of our human senses and the historical records of the people who built this city insist on calling it a volcano? To understand the true scale of this anomaly, we cannot rely solely on the digital sensors of 2026. We have to look backwards, opening a historical record that proves the fire beneath Hope Ranch is not a byproduct of modern infrastructure or recent climate shifts. This geological imposter has been burning since before the state of California even existed. In 1784, a Spanish military officer and colonial governor named Don Pedro Fages led an expedition along the uncharted coast of Alta California. As his party traveled through the area we now recognize as Santa Barbara, Fages documented a terrifying spectacle. He did not describe a single isolated vent melting a plastic pipe. He recorded an apocalyptic landscape. In the surviving Spanish archives, Fages described looking out over the coastline and counting more than 30 separate columns of smoke rising simultaneously from the cliffs. He noted that the ground was so intensely heated, his men could not safely approach the edge, and he documented the suffocating, inescapable stench of sulfur. Constrained by the scientific vocabulary of his era, Fages wrote down the only conclusion that made sense to him. He had discovered a massive, highly active volcano. This historical anchor radically changes our perspective. Today, a Hope Ranch activation typically produces 1 or 2 localized smoke vents. But Fages witnessed a mass activation event, 30 distinct thermal plumes operating at the exact same time. This massive discrepancy forces us to ask dangerous questions. Was the coastline of 1784 experiencing extreme erosion, exposing drastically more fresh rock to the atmosphere? Are we currently sitting in the dormant phase of a much larger violent cycle? Or are there dozens of latent sleeping vents scattered across the California coast, just waiting for the right conditions to reignite? It is also crucial to acknowledge that Don Pedro Fages merely wrote it down for the European record. Long before the Spanish arrived, the indigenous Chumash people thrived along this coast for millennia. They lived alongside these smoking cliffs, intimately aware of a land that occasionally breathed fire. This is not a new anomaly. It is an ancient, repeating geological rhythm, a phenomenon that can sustain itself for centuries, perfectly faking the raw, destructive power of a volcano without a single drop of magma. Cannot be a random accident. It requires an engine. It requires a vast subterranean system capable of storing an unimaginable amount of energy and a precise trigger to release it. So, what exactly is buried inside that rock? To truly comprehend the scale of the anomaly at Hope Ranch, we must examine a historical record proving this is not a modern phenomenon. It is a massive ancient cycle. In 1784, Spanish colonial governor Don Pedro Fages led an expedition along the uncharted coast of Alta California. Navigating the area we now call Santa Barbara, Fages encountered a terrifying spectacle. He did not document a single isolated puff of smoke melting a piece of plastic. He recorded a landscape that looked like the end of the world. According to surviving Spanish archives, Fages stood on the bluffs and counted over 30 separate columns of smoke rising simultaneously from the cliffs. He described the ground as so superheated his expedition could not safely approach the edge, while the air was choked with the toxic stench of sulfur. Bound by the scientific framework of the 18th century, Fages reached the only logical conclusion. He had discovered an active volcano. This historical anchor creates a chilling contrast. Today, a typical Hope Ranch activation produces 1 or 2 localized vents. Fages witnessed a mass activation event, 30 thermal plumes operating in lethal unison. This massive discrepancy forces us to ask dangerous questions. Was the coastline of 1784 experiencing an era of extreme erosion, exposing drastically more fresh rock to the atmosphere? Are we currently sitting in the dormant phase of a much larger violent cycle that is preparing to wake up again? It is also imperative to recognize that Fages merely documented it for the European record. Long before the Spanish arrived, the indigenous Chumash people lived alongside these bluffs, intimately aware of a geology that occasionally breathed fire. This is a deep, repeating geological rhythm, a phenomenon that can sustain itself for centuries. Perfectly faking a volcano without a single drop of magma requires an immense subterranean engine. To find that engine, we have to look at the rock itself. The cliffs of Hope Ranch are carved from a globally significant stratum known as the Monterey Formation. This cliff is not dead stone. It is compressed ocean history. Millions of years ago, this entire region was the floor of a highly productive ancient sea. Countless generations of microscopic marine life and organic matter drifted down into the dark, oxygen-starved depths. Over geological time, that organic mud was crushed by tectonic pressure and baked into solid sedimentary rock, but it never lost its volatile ingredients. Today, the Monterey Formation is loaded with silica, clay, and trapped fossil fuels. It is a dormant chemical battery, and it contains exactly what a fire needs: an internal heat source and an ancient fuel, just waiting for the modern atmosphere to strike the match. The answer to a 240-year-old mystery is not written in the modern atmosphere. It is locked inside the cliff itself. To understand the thermal engine operating beneath Hope Ranch, we must introduce the true main character of this investigation. The rock holding up these multi-million-dollar estates is not generic stone. It has a specific geological identity and an infamous reputation. It is called the Monterey Formation. If you want to understand why this cliff behaves like a subterranean furnace, you must first accept a profound shift in perspective. You are not looking at a wall of dirt. The cliff is not just stone. It is compressed ocean history. Millions of years ago, the landmass we now call the California coastline did not exist. This entire region was the floor of a highly productive deep-water marine basin. Above this dark, oxygen-starved abyss, the surface ocean was teeming with life. Vast, unimaginably massive populations of microscopic organisms, diatoms with intricate silica skeletons, and nutrient-dense plankton thrived in the sunlit waters. When they died, they rained down into the dark. Generation after generation, for millennia, a continuous snowfall of biological debris settled into the anoxic mud at the bottom of the sea. Because there was very little oxygen at these depths, the organic material did not fully decompose. It simply accumulated. Over geological time, tectonic forces buried this organic graveyard. The crushing weight of the layers above it, combined with the heat of the Earth's crust, slowly cooked and transformed this biological mud into a highly unique sedimentary rock. The Monterey Formation emerged from this deep-time pressure cooker as something extraordinary. It is the very same geological stratum responsible for the vast offshore oil wealth of the Santa Barbara Channel. But here, where it is thrust up to form the coastal bluffs, its chemical composition is a ticking clock. This rock is saturated with silica from those ancient diatoms, creating a highly porous, microscopic architecture. It is layered with clay minerals that act as natural chemical catalysts, but most dangerously, it is heavily loaded with two highly reactive ingredients. The first is iron sulfide, precipitating out of the oxygen-poor ancient mud, a mineral commonly known as pyrite or fool's gold. The second is an immense concentration of hydrocarbon residue. This is the unrefined, primordial ancestor of crude oil and bitumen, embedded directly into the microscopic pores of the stone. The Spanish explorers in 1784 thought they were looking at a mountain of magma. The modern residents think they are looking at a stubborn brush fire. They are both wrong. The Monterey Formation is a dormant chemical battery. For millions of years, these volatile ingredients have slept peacefully in the dark, perfectly stable as long as they remained sealed underground. But inside this rock, sitting side by side, are the two vital components that a subterranean fire desperately needs: a localized heat source and an ancient, highly combustible fuel. All this system requires to wake up is a trigger. It just needs one specific molecule to find its way into the dark, and the ancient ocean buried the ingredients. But what actually strikes the match? The answer is a piece of chemistry so brutally simple, it is almost elegant. Inside the Monterey Formation, there is a mineral called iron sulfide. You likely know it by its common name, pyrite or fool's gold. For millions of years, locked deep in the dark, oxygen-starved crust of the Earth, these golden crystals do absolutely nothing. They are chemically asleep. But the California coastline is a violent, eroding environment. When the pounding surf undercuts the bluff, or an atmospheric river saturates the soil, a section of the cliff face inevitably slumps into the Pacific. Suddenly, a fresh, unweathered cross-section of the Monterey Formation is violently exposed to the modern world, and that is when the cliff takes its first breath. When the freshly exposed pyrite is hit by atmospheric oxygen and the heavy moisture of the marine layer, a chemical reaction begins. The iron sulfide oxidizes, and this specific geological rusting process has a terrifying byproduct. It is fiercely exothermic. It generates its own heat. If this were just an isolated piece of pyrite sitting on the ground, it would simply get warm. But the Monterey Formation is not just pyrite. It is a sponge soaked in fossil fuels. Sitting mere micrometers away from the heat-generating pyrite are dense pockets of hydrocarbon residue. This is the organic ghost of that ancient ocean, the primordial ancestor of the oil that powers our modern world. It is trapped directly in the matrix of the stone. As the pyrite oxidizes, the temperature inside the rock steadily climbs. It reaches 100 degrees, then 200, then past 400 degrees Fahrenheit. The adjacent pockets of ancient oil have nowhere to go, and nowhere to hide from the rising temperature. When the heat crosses a critical threshold, the hydrocarbons begin to break down. They do not need a spark. They do not need a lightning strike or a discarded match. The ambient thermal energy from the oxidizing pyrite is enough to spontaneously ignite the ancient oil. It begins to smolder directly inside the bedrock, releasing the thick, sulfurous smoke that eventually forces its way to the surface. The cliff is, quite literally, lighting itself on fire. It requires no external ignition, only the violent collision of fresh rock, modern air, and coastal water. But this mechanism leaves us with a glaring physical contradiction. A chemical reaction generating heat is one thing, but heat naturally dissipates into the cold earth. For a cliff to melt a buried industrial drainage pipe, that heat cannot be allowed to easily escape. It has to be trapped. It has to be amplified. What turns a slow, localized chemical reaction into a runaway underground furnace? The answer is one of the most destructive forces in both physics and chemistry: a positive feedback loop. A self-amplifying cycle that turns a minor localized thermal anomaly into a raging subterranean furnace. To understand the engine driving the Hope Ranch anomaly, we have to look at how these two ancient ingredients interact in the dark. When the freshly exposed pyrite oxidizes, it generates a small but steady amount of thermal energy. Because this reaction is happening inside the microscopic pores and tectonic fractures of the cliff, the rock itself acts as a heavy insulating blanket. The heat cannot easily dissipate into the cool ocean air. It becomes trapped. As the temperature in these isolated pockets steadily climbs, it reaches the volatile hydrocarbon residues embedded in the exact same layer of stone. These ancient fossil fuels do not need a spark or an open flame to ignite. They only need to reach their auto-ignition temperature. Once that critical thermal threshold is crossed, the trapped oil begins to actively smolder and combust. This is the moment the cliff truly catches fire. But this combustion does something far more dangerous than simply producing toxic gas. It releases a massive secondary wave of thermal energy. This new intense heat from the burning oil violently accelerates the original chemical reaction. The pyrite begins to oxidize exponentially faster, which generates even more heat, which ignites deeper pockets of hydrocarbons, which drives the pyrite to oxidize faster still. The system spirals upward, feeding on itself, locked in a runaway thermal escalation. The thick yellow-tinged sulfur smoke is forced out through the geological fractures exactly like the exhaust from a mechanical engine. And this is the crucial distinction that paralyzes modern disaster response. The actual fire is completely invisible. What the residents of Hope Ranch see on the surface, the smoke vents, the sulfur stains, the heat shimmering in the air, is nothing more than the exhaust. The actual combustion is not happening on the exposed face of the bluff. It is raging in isolated pockets, 3, 10, or 20 feet deep inside solid sedimentary bedrock. This is why the temperatures involved defy our conventional understanding of a coastal landscape. At the height of an activation, the thermal core inside these fractures can eclipse 450 degrees Fahrenheit. That is hotter than the interior of a commercial oven. It is more than hot enough to flash boil subterranean groundwater, incinerate organic matter, and, most terrifyingly, melt and ignite an industrial-grade polyvinyl chloride drainage pipe buried deep inside the slope. When the Santa Barbara County Fire Department pulls up to Marina Drive, they are not looking at a wildfire. They are looking at a geological reactor core. You cannot aim a high-pressure water hose at a solid rock wall and expect it to penetrate dozens of feet of impenetrable shale to extinguish a chemical loop. You can only stand on the asphalt, monitor the perimeter, and wait for the engine to run out of fuel. But if this reaction is so intensely self-amplifying, a terrifying new question immediately arises. If a cliff can teach itself how to burn from the inside out, why doesn't the fire just keep spreading? If the fuel is in the rock, why hasn't this runaway furnace consumed the entire California coastline? When a runaway thermal feedback loop ignites inside a cliff, the most terrifying question is not how it started, but why it ever stops. If this subterranean furnace is so fiercely self-amplifying, why hasn't it eaten its way up the coast and consumed the entire city of Santa Barbara? The answer to our survival lies in the microscopic architecture of the Monterey Formation. To understand the safety mechanism built directly into this anomaly, we have to examine the geometry of geological fuel. When you look at a traditional California wildfire, you're looking at a contiguous fuel bed. The fire survives because the dry grass connects to the brush connects to the lower branches, and the branches connect to the forest canopy. It is a continuous, unbroken highway of combustible material. Even underground, in the catastrophic coal seam, fires that can burn for centuries, the fire survives because a vein of coal is a miles-long river of densely packed carbon. Hope Ranch does not have a fuel highway. It operates in isolation. The reactive pyrite and the ancient hydrocarbon residues are not distributed in a single continuous layer. They are scattered. They exist in highly concentrated pockets, locked away and isolated from one another by thick, impenetrable walls of inert sedimentary rock. When coastal erosion exposes a fresh pocket to the atmosphere, that specific cluster violently consumes the oxygen and fuel in its immediate vicinity. It burns hot, it burns fast, and it produces the dense columns of smoke we see venting at the surface. But because of how the rock was deposited at the bottom of the ocean millions of years ago, the fire eventually hits a literal wall. Once that specific pocket exhausts its locally available material, the chemistry simply breaks down. The pyrite is fully oxidized, transforming into geochemically dead iron oxide and stable sulfates. The trapped hydrocarbon residue is completely incinerated. The reaction starves itself. The intense heat from the dying pocket simply cannot bridge the gap through the inert shale to ignite the next pocket of reactive material. The cliff does not stop smoking because the fire department poured water on it. It stops because it has eaten itself into a corner. A wildfire runs, a coal seam fire crawls, but Hope Ranch burns in pockets. This self-limiting nature is exactly why the fire department stands down. They know the pocket will eventually burn itself out. The smoke will thin, the residents of Marina Drive will exhale, and the crisis will appear to have safely passed. But assuming the danger is over is a fatal misunderstanding of thermodynamics. The chemical combustion might have starved, but the massive thermal energy it created did not simply vanish. Energy cannot be destroyed, it can only be transferred. And beneath the mansions of Hope Ranch, that invisible superheated energy is still moving in the dark. When a wildfire burns across a California landscape, you can measure its perimeter. You can draw a red line on a topographic map and say with absolute certainty, the danger stops here. But subterranean geological combustion strips away that luxury. The most terrifying aspect of the Hope Ranch anomaly is not what you can see. It is the illusion of safety created by what you cannot. When the smoke thins out and the fire department leaves, human psychology assumes the event is over. But the smoke escaping from the face of the bluff is nothing more than a localized bleed point. It is merely the exhaust valve for a system operating deep within the dark. The absence of smoke does not mean the absence of danger. The actual reaction zone, the thermal core where the pyrite and ancient hydrocarbons are actively colliding, might be located 10, 20, or 50 feet back into the solid slope. And because the Monterey Formation is highly porous and heavily fractured, the massive thermal energy generated in that core does not stay put. Heat is a relentless traveler. It migrates outward through pure conduction, baking the surrounding shale. It rides on currents of superheated steam from vaporized coastal groundwater. It pushes toxic high-temperature gases through a labyrinth of microscopic cracks. This is exactly why the melted polyvinyl chloride drainage pipe from the April 2026 event is the most critical piece of evidence in our entire investigation. That PVC pipe was not positioned inside an active smoke vent. It was buried in what appeared to be stable, cool earth, far from the visible anomaly. Yet, it was subjected to temperatures exceeding 400 degrees. The heat had migrated through the dark, silently hunting through the bedrock until it collided with human infrastructure. This redefines the true nature of the threat to the multi-million-dollar estates sitting on the precipice. The primary risk is not a towering wall of flame consuming a neighborhood. It is the invisible slow-motion failure of subterranean infrastructure. It is power conduits melting. It is water lines warping and bursting underground. It is the structural integrity of the cliff itself, degrading as the rock is repeatedly superheated and cooled, turning solid stone brittle and drastically increasing the likelihood of a catastrophic landslide. It is a uniquely frustrating disaster profile. It is not an apocalyptic event that triggers mass evacuations, but it is far too dangerous and far too unpredictable to safely ignore. Emergency responders are effectively flying blind. You cannot easily map the internal thermal halo of a burning cliff. You cannot X-ray the rock in real time to predict where the heat will pool next. But heat and pressurized gas are fundamentally lazy. They will always follow the path of least resistance. If this invisible thermal energy is navigating through the bedrock to find its way to the surface, it must be using a pre-existing network. So, what underlying invisible architecture is actually dictating where the cliff decides to breathe? If this massive invisible thermal energy is navigating blindly through solid rock, how does it consistently find its way to the surface? The answer requires us to look at the cliff not as a solid block of stone, but as a shattered pane of glass. Santa Barbara County exists within one of the most structurally violent tectonic environments on the North American continent, the Western Transverse Ranges. Unlike most mountain ranges in California that run north to south, these mountains run east to west. For millions of years, the bedrock here has been caught in a geological vice. Lifted, twisted, intensely compressed, and violently shattered by the relentless grinding of tectonic plates. This ancient tectonic torture has left the Monterey Formation riddled with deep, jagged fracture zones and active fault lines. When the general public hears the phrase fault line, they immediately think of seismic destruction. They think of earthquakes. But in the context of subterranean geological combustion, a fault line serves an entirely different purpose. It is invisible plumbing. These microscopic cracks and massive tectonic fractures act as a highly efficient, two-way, deep earth ventilation system. They are the respiratory tract of the anomaly. When coastal erosion tears away the outer layer of the bluff, it opens these fractures to the ocean breeze. They act as intake valves, channeling atmospheric oxygen and coastal moisture deep into the dark, delivering the exact chemical triggers the dormant pyrite needs to begin its exothermic reaction. But as the heat exponentially builds and the trapped hydrocarbons ignite, these exact same tectonic fractures reverse their function. The immense pressure generated by the burning ancient oil forces the superheated sulfur gas, steam, and thermal radiation upward. The heat hunts for the path of least resistance, following the jagged fault lines through the darkness until it violently vents at the surface. This hidden plumbing explains one of the most baffling mysteries of the Hope Ranch anomaly. It explains why the fire department and the residents see smoke appearing in the exact same specific locations, year after year, decade after decade. The fire is not choosing where to burn at random. It is strictly obeying the shattered architecture of the rock. The cliff breathes exactly where the ancient faults have given it a throat. The fire follows geology that we cannot see. If geophysicists possessed a microscopic, three-dimensional map of every subterranean fracture stretching beneath the estates of Marina Drive, they could theoretically predict exactly where the next smoke vent would open. They could warn homeowners exactly which buried utility lines were sitting inside a thermal crosshairs. But that map does not exist. The residents are living on top of a blind maze, and they only know where the tunnels are when the smoke finally pours out. But a plumbing system is completely useless unless it is connected to a reservoir. If these fault lines are acting as the pipes, channeling oxygen in and toxic exhaust out, we have to ask, what else is migrating through this shattered rock? What massive continental-scale energy system are these fractures actually tapping into? To understand the true magnitude of what is happening beneath Marina Drive, we must follow these tectonic fractures out of the cliff and into the abyss. Because the Monterey Formation does not end at the California shoreline. The exact same layer of organic-rich sedimentary rock that holds up the mansions of Hope Ranch plunges directly beneath the waves, extending for miles beneath the Santa Barbara Channel. And out there, in the freezing, oxygen-deprived depths, this stratum is doing exactly what made it world famous. It is bleeding oil. The Santa Barbara Channel is one of the most prolific natural hydrocarbon seep areas on the planet. Every single day, massive volumes of raw petroleum and natural gas escape the fractured seafloor, bubbling up through the water column to form natural oil slicks and wash ashore as sticky black tar. The towering offshore drilling platforms and the infamous devastating 1969 oil spill are intimately tied to this exact same subterranean reservoir. The underwater seeps and the burning cliffs of Hope Ranch are two drastically different expressions of the exact same geological phenomenon. When this heavily fractured, oil-soaked rock is submerged beneath hundreds of feet of cold seawater and sealed away from atmospheric oxygen, the ancient hydrocarbons simply leak. The system remains quiet, bleeding its stored energy slowly into the ocean. But when tectonic uplift and relentless coastal erosion push that exact same rock above sea level, the physical rules violently change. On shore, the rock is no longer insulated by the ocean. It is brutally exposed to the modern atmosphere. The pyrite collides with the oxygen. The deep tectonic plumbing draws the air inside, and the hydrocarbons do not just seep into the water. They are trapped in a superheated matrix and forced to combust. Hope Ranch is not a random, isolated anomaly. It is, quite literally, a dry oil seep. It is a place where the ancient petroleum system of the California coast is forced to burn itself alive because it has run out of ocean to hide beneath. We are not just looking at a strange cliff fire. We are standing on the exposed, burning edge of a continental-scale energy system. But recognizing this immense scale introduces a massive, glaring scientific contradiction. Pyrite is everywhere. Hydrocarbons exist in sedimentary basins all over the world. Oxygen and coastal moisture are universal. If that is all it takes to make a coastline spontaneously combust, why isn't every exposed shale formation on Earth a smoking ruin? To understand the true anomaly of Hope Ranch, you must confront a glaring scientific contradiction. If you walk into a gift shop anywhere in the world, you can buy a piece of pyrite. Hydrocarbons are trapped in sedimentary basins beneath half the continents on Earth. Oxygen makes up 21% of our atmosphere, and coastal moisture is ubiquitous. If fuel, oxygen, and water are all it takes to make the ground spontaneously combust, then every exposed shale formation on the planet should be a smoking ruin. Every road cut through an ancient seabed should be venting toxic sulfur. Yet they are not. Cliffs generally do not catch fire. The Hope Ranch anomaly is strikingly, almost impossibly rare. This rarity reveals the most critical aspect of the phenomenon. The ingredients for this subterranean fire are incredibly common, but having the ingredients does not build the engine. You also need the perfect reactor vessel. The Monterey Formation at Hope Ranch acts as a naturally engineered catalyst bed. For this specific chemical ignition to occur, the rock must possess a flawlessly calibrated internal architecture. It requires a specific porosity, microscopic gaps created by those ancient diatom skeletons that allows oxygen to penetrate deep into the stone. It requires a high concentration of clay minerals, which actually act as chemical catalysts, lowering the energy threshold needed for the pyrite to oxidize. But structure is only half the equation. The environment must also execute a perfect balancing act. Consider the moisture. The exothermic oxidation of pyrite requires water, but too much of it is fatal to the fire. If this cliff were located in a tropical rainforest, the heavy precipitation would flood the rock and immediately quench the rising heat. If it were in a bone-dry desert, the pyrite would starve for the moisture required to initiate the reaction. The unique, persistent marine layer and coastal fog of Southern California provide the exact Goldilocks ratio of atmospheric water. Then consider the erosion. The cliff must be actively crumbling to expose fresh, unweathered pyrite to the air. If the coastline recedes too slowly, the rock oxidizes harmlessly over decades, never building enough heat. If the cliff collapses too violently, the reaction zone falls into the ocean before the temperature can reach the auto-ignition point of the hydrocarbons. It requires a precise, steady rate of destruction to keep the engine fed. This phenomenon is what geophysicists call activation sensitive. It is a geological combination lock with a dozen heavy tumblers. You need the pyrite, the ancient oil, the clay catalysts, the insulating rock, the tectonic plumbing, the perfect humidity, and the exact rate of coastal erosion. If a single variable is missing, the tumblers do not align, and the system sleeps forever. Most coastlines on Earth possess 2 or 3 of these variables. Hope Ranch is the rare, terrifying location where every single box on the checklist is perfectly marked. The ingredients are common. The arrangement is a statistical miracle. But as researchers drill deeper into this statistical miracle, they are encountering an anomaly that defies pure chemistry, because there is a growing suspicion that the fire inside this cliff is not just a thermal reaction. There is a wild card hidden in the dark, a variable so strange it suggests the cliff might not just be burning, it might be breathing. As geochemists drill deeper into the statistical miracle of Hope Ranch, they are encountering an anomaly that defies pure chemistry. There is a growing suspicion that the fire inside this cliff is not just a thermal reaction. It might be partially alive. To understand this, we must look at one of the most hostile environments on Earth: abandoned, flooded mining shafts. In these dark, highly acidic ruins, scientists identified a species of extremophile known as Acidithiobacillus ferrooxidans. This is a chemolithotroph, a biological classification that translates literally to rock eater. It does not consume organic food. It sustains its metabolism by drawing energy directly from the chemical bonds of iron and sulfur. When pyrite is exposed to air and water, it naturally oxidizes. But when Acidithiobacillus ferrooxidans is introduced to the environment, it acts as a biological hypercatalyst. The bacteria strip electrons from the iron sulfide at a staggering rate, accelerating the oxidation process by orders of magnitude. They are the primary architects of acid mine drainage, turning the runoff of abandoned mines a toxic, violently bright orange. Now apply that biological engine to the cliffs of Santa Barbara. Inside an active Hope Ranch fracture, the conditions are exactly what these extremophiles require. It is dark, it is saturated with iron sulfide, and it is bathed in coastal moisture. The hypothesis currently haunting geological circles is that the Monterey Formation is not just a chemical reactor, it is an incubator. If these bacterial communities are thriving inside the fractures of the cliff, they would fundamentally alter the thermodynamics of the anomaly. The slow, natural oxidation of the pyrite would be hijacked by a biological metabolism. The bacteria would aggressively consume the minerals, driving the temperature upward at a highly accelerated rate until the ambient heat crosses the ignition point of the trapped ancient oil. If this hypothesis is true, it forces a radical shift in how we understand the threat. The cliff is not just burning, it is digesting itself. We are looking at a coupled biogeochemical engine, a process where microscopic life, ancient geology, and the modern atmosphere are all participating in the exact same thermal cycle. The fire is, in a very strange sense, the metabolic exhaust of an organism eating the earth. This remains an open hypothesis. To definitively prove the presence of these extremophiles, a team would have to drill directly into the thermal core of an active vent, a virtually impossible task given the extreme heat, toxic sulfur gases, and structural instability of the crumbling cliff. The fire is keeping its biological secrets locked safely in the dark. But whether the engine is purely chemical or driven by a microscopic metabolism, it forces us to confront a terrifying parallel. Because there are other places on Earth where buried fuel, oxygen, and subterranean heat have collided. Places where the fire did not stop. Places where the ground has been burning for decades, or even millennia. If Hope Ranch shares the exact same physics as the most catastrophic underground fires in human history, what prevents this affluent California neighborhood from suffering the exact same apocalyptic fate? If you want to understand the true terror of a fire you cannot extinguish, you have to look beyond the California coastline. Because the anomaly beneath Hope Ranch does not exist in isolation. It belongs to a rare, catastrophic family of planetary phenomena known to science as geological combustion. To grasp the apocalyptic potential of these subterranean engines, we must look at what happens when the Earth possesses an unlimited supply of fuel. In 1962, in the small mining town of Centralia, Pennsylvania. A routine landfill fire was ignited to clear trash, but the fire found a hidden fracture in the earth. It crept downward, slipping into the massive abandoned coal seams running directly beneath the community. Once the underground coal ignited, it became an unstoppable force of nature. For over 6 decades, the ground beneath Centralia has been burning. It buckled the highways, poisoned the air with lethal levels of carbon monoxide, and opened terrifying sinkholes of superheated earth. It forced the federal government to condemn the entire zip code and permanently evacuate the population. Today, Centralia is a toxic ghost town, and geologists estimate the subterranean fire will continue to burn beneath the ruins for another 250 years. But even Centralia is a brief spark compared to what happens when this phenomenon truly scales. In Australia, there is a place called Burning Mountain. The name is not a metaphor. Deep beneath the surface, an underground coal seam has been actively smoldering for at least 6,000 years, moving southward at a rate of roughly 1 meter per year. The subterranean fire bakes the soil from the inside out, leaving behind a scorched, chemically altered dead zone. It has survived ice ages and massive climatic shifts. It is widely considered the oldest continuous fire on Earth. Centralia, Burning Mountain, Hope Ranch. These vastly different landscapes are united by the exact same unforgiving fundamental physics. They all require buried fossil fuels, a tectonic pathway for atmospheric oxygen, and a trapped thermal core capable of sustaining combustion. They are all expressions of planetary energy violently escaping its containment. And this is the realization that quietly haunts the residents of Marina Drive. If the physics driving the Hope Ranch anomaly are virtually identical to the underground fires that permanently erased a Pennsylvania town, what prevents this multi-million-dollar California enclave from suffering the exact same apocalyptic fate? If the cliff is on fire, what stops it from turning into Centralia? The fear of a coastal Centralia is a powerful psychological specter. If you live on Marina Drive, the idea that the ground beneath your foundation could burn for the next 2 centuries is paralyzing. But science offers a definitive boundary to this nightmare. Hope Ranch will not become Centralia. And the reason why has everything to do with the architecture of the fuel. To sustain an endless underground fire, you need density. Centralia is fueled by solid veins of coal. A coal seam is a subterranean highway of densely packed, continuous carbon running for miles. Once a fire establishes itself on that highway, it never runs out of road. The combustion front simply crawls forward, inch by inch, following the unbroken vein of fuel. The geology of the Monterey Formation is fundamentally different. It does not possess a highway. It is a labyrinth of locked, isolated rooms. The reactive pyrite and ancient hydrocarbon residues beneath Santa Barbara are highly diluted. They are scattered throughout the cliff in tiny pockets, separated from one another by massive thick layers of inert clay and silica. When a specific pocket is exposed to oxygen, it triggers the runaway thermal feedback loop. The trapped oil ignites, and the rock vents toxic smoke. But once that specific localized cluster of fuel is incinerated, the fire hits a literal wall of dead stone. The intense thermal energy generated by that single burning pocket is absorbed and dissipated by the surrounding inert shale long before it can reach the ignition temperature of the next pocket. The fire starves. It does not travel. It activates, consumes its immediate surroundings, and dies in place. This geological flaw guarantees that Hope Ranch can never sustain a moving combustion front. The estates above will not be swallowed by a decades-long inferno. But this does not mean the anomaly is harmless. Instead of a fatal disaster, Hope Ranch suffers from a chronic condition. It will repeatedly activate, generating localized thermal spikes capable of melting underground utilities, degrading the structural integrity of the cliff, and forcing emergency responders into a perpetual state of observation. If the geology prevents a continuous fire, we are left with a series of isolated events. The anomaly resets after every burn, waiting for the next pocket to be exposed. Which brings us to the most urgent question for the future of this coastline. If the fire is just waiting in the dark, what exactly is controlling the clock? What environmental trigger decides when the next piece of rock will be thrown to the atmosphere? To predict when the Hope Ranch anomaly will wake up next, we must identify the master clock controlling the system. And to do that, we must address the most scrutinized force in modern science, a changing climate. Let us be absolutely clear. Climate change did not create the fire beneath Santa Barbara. Don Pedro Fages watched this coastline burn in 1784, long before the industrial era. The engine is ancient, but while the climate did not build the engine, it absolutely controls the throttle. The limiting factor for this combustion is exposure. For the pyrite to oxidize and the ancient oil to ignite, the rock must be violently broken open to let oxygen inside. The fire relies on destruction. It requires coastal erosion. It requires the relentless surf to undercut the bluff and heavy winter storms to destabilize the soil until a section of the cliff slumps into the sea. This is where modern climate intercepts ancient geology. As the environment shifts, the mechanics of erosion accelerate. Sea levels are creeping upward, bringing wave action higher against the bluff. Furthermore, California is increasingly defined by extreme precipitation events, atmospheric rivers that dump staggering volumes of water in a matter of hours. When these atmospheric rivers saturate the cliffs of Hope Ranch, the rock becomes heavy and prone to failure. The math is brutal. More extreme weather leads to faster coastal erosion. Faster erosion means more fresh, unweathered layers of pyrite and oil are abruptly thrown into the open air. Climate change did not create the fire, but a destabilized coastline dictates how often the fire gets a chance to breathe. If the cliff erodes faster, the probability of these subterranean ignition events will inevitably rise. Yet despite this trend, the anomaly refuses to be perfectly modeled. We cannot look at a weather forecast and predict exactly which day a buried pipe will melt. The system has too many hidden variables. The cliff burns on its own erratic schedule. We are left with a scientifically understood mechanism posing a highly unusual threat. We know exactly what it is, which makes it entirely baffling that for 240 years, we have insisted on calling it by the wrong name. We have dissected the chemistry. We have mapped the invisible tectonic plumbing. We have definitively established that the thermal engine beneath Marina Drive is fueled by oxidizing pyrite and ancient fossil fuels, completely devoid of magma. Yet, if you walk into a coffee shop in Santa Barbara today and ask about the smoke on the cliffs, the locals will not tell you about a sedimentary, self-heating anomaly. They will tell you about the Hope Ranch volcano. This brings us to a fascinating psychological mystery. Why has a fundamentally incorrect label survived for 240 years, even in the face of absolute scientific consensus? The answer lies in how the human brain processes the unknown. We do not naturally reason from first principles. We pattern match. When we are confronted with overwhelming sensory data, the choking stench of hydrogen sulfide, the intense thermal radiation, and plumes of smoke jetting directly from bedrock, our brains frantically search our mental archives for a matching file. For the average human being, there is only one file that contains all three of those extreme variables: a volcano. When Don Pedro Fages stood on the bluffs in 1784, he interpreted the landscape through the scientific framework of his era. He saw the cues and wrote the word down in the Spanish colonial record. But the fact that modern residents, living in the golden age of satellite telemetry and geophysics, still use that exact same 18th century vocabulary reveals the stubborn power of a catchy narrative. Dead. The Hope Ranch volcano survives because it is romantic. It is short, punchy, and highly visual. But this linguistic convenience comes at a dangerous cost. A wrong name actively hides the true mechanism of the threat. When you call it a volcano, you look for a deep geothermal magma system that isn't there, and you ignore the complex shallow biochemical reactions that actually are. The scientific community has attempted to correct the record with precise terminology. They call it a geochemical combustion event, a shallow sedimentary combustion system, or a coastal geochemical fire. But these terms are clunky and academic. They die in peer-reviewed journals because they fail to capture the visceral, terrifying reality of standing next to a burning cliff. The wrong name sticks because everyday human language lacks a dedicated word for this specific geological nightmare. The persistence of the volcano myth is a humbling reminder of our own psychological limitations. Science is not just the pursuit of new answers. It is the exhausting, centuries-long battle to correct the inaccurate labels our own evolutionary senses have forced upon the world. If a mistaken identity can survive for 2.5 centuries in one of the most highly educated zip codes in America, it begs a chilling question. How many other extreme natural phenomena on this planet are we currently misunderstanding simply because our brains slapped the wrong label on them? To answer that, we must strip away the myths. We must draw a hard, unforgiving line between what we have definitively proven and the terrifying variables this cliff still refuses to surrender. In an era dominated by clickbait and apocalyptic headlines, true investigative science requires a rigid, almost ruthless discipline. To truly understand the Hope Ranch anomaly, we must draw a brutal line in the sand between the hard data we have definitively proven and the secrets the cliff is still hiding in the dark. Here is what we know with absolute peer-reviewed certainty. This is not a volcano. There is zero magmatic activity beneath the Santa Barbara coastline. The thermal engine is the Monterey Formation. We know the heat is initially generated by the exothermic oxidation of pyrite, and then aggressively amplified by the spontaneous combustion of ancient hydrocarbon residues. We know this reaction is incredibly shallow, occurring feet, not miles, inside the solid bedrock. And crucially, we know the system is inherently self-limiting. Because the geological fuel is distributed in isolated, disconnected pockets, it cannot trigger a catastrophic, continuous subterranean inferno. It has burned like this for centuries, and it will not suddenly swallow the mansions of Marina Drive. But the margins of this phenomenon are filled with shadows. The list of what we do not know is deeply unsettling. We heavily suspect that tectonic fault lines act as the invisible plumbing, dictating exactly where the toxic smoke vents to the surface. But we do not possess the high-resolution, subterranean radar maps required to prove it. We hypothesize that extreme coastal erosion, accelerated by a shifting climate, will increase the long-term frequency of these ignitions, but we cannot predict the exact day, month, or even year the next pipe will melt. And hovering over all of this is the microbial wild card. We strongly suspect that rock-eating extremophiles might be hijacking the chemistry, hypercatalyzing the heat to ignition temperatures. But until a scientific team can safely extract a biological sample from a fractured, unstable 400-degree thermal core, it remains a terrifying theory, not a confirmed reality. This discipline forces us to reject the easy narratives. We cannot claim this is a dormant volcano waking up. We cannot say it is the prelude to a massive earthquake, or that climate change directly struck the match. This restraint is what makes the anomaly so profoundly compelling. We do not need to invent a Hollywood doomsday scenario to make Hope Ranch fascinating. The reality is unsettling enough. The ultimate truth of the Hope Ranch anomaly is not that it is vastly more dangerous than we calculated. It is that the Earth is vastly stranger than we have the vocabulary to describe. Which leaves us with one final sobering question. When the smoke finally clears, what exactly is the cliff trying to tell us? When we pave a road, lay a foundation, or sign a deed to a piece of coastal real estate, we engage in a quiet psychological fiction. We tell ourselves that the Earth is a static, finished product. We operate under the assumption that the ground beneath our feet is a passive, obedient stage, quietly waiting for human beings to build the future upon it. The burning cliffs of Hope Ranch shatter that illusion entirely. The true warning beneath the cliff is not about an impending apocalyptic eruption. The threat is deeply philosophical. This anomaly forces us to confront the terrifying friction between human time and deep geological time. Human time is measured in 30-year mortgages, rapid emergency response protocols, and the daily news cycle. Geological time is measured in millions of years of microscopic marine snowfall, the slow, agonizing crush of tectonic plates, and the gradual uplift of an ancient ocean floor. We built our luxury estates at the exact coordinate where these two irreconcilable timelines violently collide. When the residents of Marina Drive look down at the sulfurous smoke venting from the bedrock, they are not just looking at a weird chemical reaction. They are looking at the Earth's memory. The cliff is actively remembering a time before human beings existed, processing primordial biological energy that was trapped in the dark long before the first hominids ever walked upright. In our modern industrialized society, we possess the arrogant assumption that we have monopolized combustion. We drill the oil, we refine it, we pipe it into our machines, and we firmly believe that we control the flame. Hope Ranch strips away that hubris. It proves that the planet possesses its own raw, unrefined thermal engines. It is a stark reminder that the Earth is a vast, interconnected reservoir of volatile energy that does not require human permission or human ignition to burn. We cannot extinguish this engine. We cannot predict its exact schedule. We can only stand on the asphalt, map the invisible thermal bleed, and wait for the ancient fuel to temporarily exhaust itself. The Hope Ranch anomaly is not a monster. It is not a dormant volcano waiting to destroy a city, and it is not a harbinger of the end of the world. It is simply physics, chemistry, and deep time operating exactly as they must. Our responsibility is not to conquer it, nor to hide from it behind the comforting fiction of an inaccurate centuries-old name. Our responsibility is to look at the smoke, smell the sulfur, and accept the profound, humbling reality of our place in the universe. We do not own the Earth. We are merely temporary tenants, balancing carefully on the thin, fragile crust of a world that is still very much alive, still breathing, and still burning in the dark.